Okay, so today we're going to just dig into a little bit about the history of electricity. Okay, so at the end of today, you should know what the contributions of Buffet and Franklin are to understanding electricity. So you should know those names and kind of what they've done. You should know the 1 and 2 fluid models. You should understand that scientific models change over time and the reason for this. And you should also, with a partner, decide on a definition of electricity. Already done. Already done. And it was at that link right there. I just used that to sort of remind myself. Okay. So, oh, and by the way, everything that I say is being recorded on my handy-dandy microphone right here, and everything today will be posted up to YouTube before you get home. If you enjoyed today's lesson so much, you can watch it in a repeat later tonight. It'll be awesome. You will just see everything that's on the screen, a screencast, and you will hear my lovely voice.
So right now we'll be able to hear.
Yeah. If you talk loud enough, it's yours. I'll show you at the end. Okay, so let's talk about the ancient Greeks. They lived in houses like that, had good air conditioning because they hate it because it's hot there. Anybody know what the name of that is in Greece? That place?
Oh, yeah, we live that.
Yeah, remember? Up on a big hill. I've been there. It's very cool. No, it's not the Colosseum. It's a Parthenon, yes. That building is the Parthenon, and the big hill is called the Acropolis. It's actually quite steep and pretty interesting site if you ever get a chance to go there. Okay, so the Greeks knew about static electricity and the existence of 2 types of charges. Now, observer, you're going to have to turn around because some of the things are not on that sheet. You're going to have to write them in. In the 1700s, so yeah, jump from ancient Greece. In the 1700s, I knew what I was going to show you. I'll show it at the end. In the 1700s, ideas were emerging that some objects were electrics. They were attracted to other objects when rubbed, and others were non-electric, some did not attract. Can you think of any example? With your partner, see if you can come up with an example of something that is electric and something that is not electric when rubbed. What is something that attracts or has static electricity, and what is something that doesn't? Write it down, quick. Something that is electric.
Fuzzy things.
Fuzzy things.
Like a fuzzy blanket.
Fuzzy blanket, wool. Wool socks. Carpet.
And your hair.
If we have it, our hair.
Steven.
Balloon, all good. Okay, who has an example of non-electric? Wood?
What can be?
Yeah, I don't think wood. Anyone else got one?
It can be.
Rubber? That's another good one.
Water.
Yeah, that'd be wood, right? Let's just leave it like that. Okay. Okay, so this guy who had really good hair looked like he should have been. He looked like he should have been playing guitar back in the 80s. Right? Name of Charles Dufay. He discovered that a cork ball touched by an electrified glass rod and a different cork ball touched by an electrified resin rod would attract each other. Why? What is your, here in 2014, why do you think that if you take the fur and you rub it on the glass and then you touch the cork ball, and you take the fur and you rub it on the resin, you touch this cork ball, why do you think that would cause them to go together?
Oh, I know.
Nowadays. We know why, right?
Yeah.
Someone said it earlier before up here. Positive, negative, right? But they didn't know about that stuff. They tried to come up with some reasonings besides magic, okay? This was his thought. Now, are you following along? Because you need to write some stuff down, right? Okay, so here was his model. So Dufay believed that there were 2 kinds of fluids, is what he called them. What's the word fluid mean in today's age?
Water.
Water, liquid. Actually, a gas is a fluid too, but. So he said that there were 2 kinds of fluids, and he called them vitreous electricity. I'm just going to do this here for you. He called them vitreous electricity. Vitreous is the Latin word for glass. So,
those are also types I know.
yeah? So when he rubbed the fur on the glass rod, he said that he was producing vitreous fluid. And then the other one he called resinous electricity, because when he rubbed the fur on the resin, on that Jurassic Park stuff, fossilized amber, that he got a different kind of fluid. He also said that all objects contain both fluids. Okay? Everything had resinous fluid, everything had vitreous fluid. Vitreous objects that had a vitreous charge contained more vitreous fluid, and resinous objects obviously contain more resin. Does that kind of make sense to you? Does that explain the whole charge thing, why things attract and repel and that kind of stuff? Well, it's a good start, right? It's a good start. He also said that when a vitreous object like this black one here comes in contact with a resinous object, the fluids travel to one another to balance out, and then they both end up being non-charged. So he said all the white fluid here, the vitreous fluid, would go there, and all the resinous fluid would go there, and it would sort of even out and balance. Kind of like taking water and, pouring them back and forth and sort of coming to a level, which would be then neutral. Does that make sense? Sort of, kind of? Okay. There are 3 problems with this. Do you have them on your sheet?
Yes.
Oh, that's too bad, because I was going to say, what do you think they would be? Well, the first problem is, what happens when 2 vitreous objects touch? They pull apart, but because vitreous fluid would only go into sort of where there's not vitreous fluid, right? Then nothing should happen here. And what happens when 2 resinous objects touch? Yeah, but that's kind of not what happens. And the third one was, this is the key one, why do objects attract and repel? Should everything attract everything else? Like if I've got a deck of cards that's got vitreous electricity to it, and I've got a pen that has neutral, right? How come this isn't attracted to it? It's neutral, right? We know nowadays it's got to be positive and negative for it to retract. You guys need to listen. Yeah, you need to listen. Well, there is a problem. You're not listening. Or not. Thank you. Okay? So these were all problems with Dufay's model. It really didn't explain everything. Okay? Why are vitreous things not attracting neutral things? Because there shouldn't be there needs to be a balance there, and it wasn't happening. So you guys probably know this guy, right?
Yeah.
Ben Franklin. Everyone knows Ben Franklin.
He had the key.
We'll get to the key on the kite. He's the key on the kite guy. He's probably like one of the most famous sort of science dudes there is out there, right? He rejected Dufay's model. He said, you know what, Dufay, you're crazy. Look at that hair. What are some other examples of scientific models that have changed over time that you know of? Anyone know? Might be a hard question for grade 9. There's one that you probably should know.
And you repeat the question.
What are some scientific models that have changed over time? Well, first of all, let's step back a little bit here. What is a scientific model? Bingo, that's what I'm looking for. Go ahead, Brian. What's a scientific model? Say that again? Oh, Archimedes, yeah. That's not really a model. It's a good story, but. What do I have in my hands here? I have a globe. Is this a scientific model? A scientific model is really a physical representation of something we can't really see or understand. Now, can we see the Earth? Yes. Can we see it in its entirety? Not unless you go into outer space, right? And think back to ancient Greeks. Their model of the Earth was that the Earth was? Flat. There's still people that believe that. Yes, hard to believe. Google up Flat Earth Society. That model of the Earth has changed, right? Because why? Well, we've gone into space and we've seen that it's round. Okay, think bigger than the model of the Earth.
Solar system.
Solar system model. At one point, they believed that. Can you get that yellow ball out of there for me, please? At one point, they believed that what was the relationship between the sun and the earth? What revolved around what? They believed that the sun. Thank you so much. They believed that the sun revolved around the earth. Right now, imagine this to be the sun. Ooh, it's hot. It's for a sound demonstration. Yeah, I'm just using it for this yellow, right? Is this scale to the earth? No, the sun is like giant, right? But anyways, it's yellow. They at one time believed that the sun did this and revolved around the earth. How come? Because that's what we see every day. You wake up in the morning and you see the sun rise in the east and you go, oh yeah, okay, sun goes around.
Yeah.
That's not what's happening. What's happening? Yeah, it's this, right? The earth is rotating as the sun stays in place. And we now know that the earth actually does this, right? So scientific models have changed over time. So what are other examples of models that have changed over time? Model of Earth has gone from flat to round. And are you writing this down? And the model of the solar system. And there are others as well that you're going to learn more about in chemistry, certainly. Okay, so this is what happens. Scientists take other scientists' work and they critique it, they fix it, they edit it, they reject it, then they say, oh no, I was wrong, they go back. Things evolve, things change over time. Scientific models change. So Ben Franklin said, Dufay said, there's two fluids. Franklin said, no, there's one fluid. And he used the terms, he was the first guy to come up with the terms positive and negative. Now, I could spend hours talking to you about a controversy here. Okay? There are some people who will say that Franklin got it wrong. That he should have said the positive is the negative and the negative is the positive. And it's kind of a confusing story. It's got to do with the electrons and what moves in electricity and blah, 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 blah. Suffice to say, there's lots of controversy and it hasn't really been resolved. Some people believe Franklin made a mistake. Some people believe he made a mistake on purpose, and some people believe that the mistake actually turned out to be a little bit better because it forces people to think about it. It's all quite confusing. I'm not going to worry about it. All you need to know is that Franklin was the guy that came up with positive and negative, and came up with this one fluid model. And he said that neutral objects had just the right amount of fluid, positive had too much of this electric fluid, and negative had not enough fluid. What's the picture of? No. I call this, what is it? The Goldilocks model, because too hot, too cold, just right. Okay? So Franklin came up with that when it's just the right amount, then it's neutral. When there's too much of this electric fluid, it's positive. When there's not enough, it's negative. The Goldilocks model. Goldilocks model.
Hey guys.
Okay. Does this solve the three problems with Dufay's model? Does it solve, well, let's just jump right to number 3. Does it solve why do objects attract and repel? It does. It does, okay? It solves the problems with Dufay's model. It does solve, should everything attract everything else? Because that's what Dufay's model suggested, and it's not true. Neutral is just the right amount, okay? You can't pour extra into there, kind of thing. It's kind of confusing. It's generally accepted that Franklin's model was an upgrade over Dufay's model, and it became sort of our basis for the next one, which we'll talk about a little bit more next time. Okay. Have you guys ever done 3-point approaches?
Yes.
Yes? So you've seen them before. Excellent. I've never done them, so you're going to show me. So let me just, first of all, we're going to make 2 entries here. So the first one is going to be the 2 fluid model. So I'd like you to, in the middle there where it says word or concept, I'd like you to write two fluid model right there, where it says word or concept, two fluid model. And in fact, I'm going to take that. Oh, and I spelled it wrong. It's not Dufay, or Dufray, it's Dufay. So under word concept, I'd like you to write two fluid model. And under synonym or example, write Dufay. Because a synonym means what? Synonym. Not what you put on your oatmeal in the morning. Synonym means like another word for it, right?
Oh, you said thing.
Yeah, I know. And then I caught myself. So the name of the concept is the two fluid model. The synonym is Dufay. Now definition, that's where you kind of put what it's all about. What would you say? I've got two fluids, something and something. He's the guy that said vitreous and resinous. Right?
There.
I gotta find my notes here. Here we go. That's what I want. Vitreous and resinous. And if they're both equal, then if there's the same amount, then it's neutral.
With all grade 11 classes, please report to the multi-purpose room for the presentation. Please, that's all grade 11 classes. Thank you.
Okay, can we draw a diagram here? Here's what I want you to draw. Just sort of draw like a oval. Put a line down the middle and put V and R. What would that be? Vitreous and resinous, and this overall object would be neutral. And then what else should you draw, do you think? I'm going to draw two more. One with the line there and one with the line there. V and R, V and R. When there's extra V, then it's called vitreous. Remember, Dufay didn't know about positive and negative. He didn't use that. When there's extra R, that means it is resinous. Is that a good way to describe the two fluid model? It shows you in words, it shows you in a diagram, right? Kind of like your own little personal cheat sheet. Do you think you could complete the Franklin one on your own? How about I do that, the one fluid model? I'll give you a start, and I'll come back and I'll give you the answer right away. Right now I'm going to write down the one fluid model three-point approach here. So the concept is one fluid model. Did you put Franklin under the synonym? Positive is equal to what? Excess fluid? Or how about I put extra instead of excess? Or too much? I'll put it in simpler terms. I'll say too much. Negative is not enough. And neutral is Goldilocks, just right. And in fact, maybe we should have under definition there, we should say one type of fluid. Do we need to say that? Or is that sort of in the name? I guess it's in the name, really, isn't it, right? The concept is the one fluid model. What does one fluid mean? There's only one fluid. Okay, good enough. Here's the diagram that I drew. Imagine a glass. When it's negative, then that means not enough. It's down there. When it's positive, that means there's too much. Now, how are we going to show too much? Overflowing. And neutral, just right. Which one of these concepts do you think is closest to what today's idea is? And I don't really want an answer, but I want you to think about that a little bit. Which one is closest to today's understanding? Which I haven't really taught you, but you probably have some idea. Dufay said there was two different things. Nowadays we know about positive and negative. Franklin said no, there's only one thing that's got to do with when there's too much and too little. I'm just going to let you think about that. Okay. Did Franklin really fly a kite in the thunderstorm? Do you know?
Yes.
Let's see.